What's up, everybody? Today we got some tricky induction. So what the fuck are we doing here? Firstly we have a recursion. Okay, so we have that an plus 1 is equal to 5an minus 6an minus 1. Okay, so we have a recursion based on the two previous values. Okay, and we have some starting positions here because we have to do two because we're referring to 2, and then we have our statement here. Prove that an is equal to 2 to the power of n plus 3 to the power of n for all n's belonging to the natural domain. What should we do now? Well, we just start with the base case, with the first case. So what is our first case? Well, it's obviously not any of those. We actually have to check if n is equal to 3 works. So how do we do that? Well, we check if both hold. So what is that? Okay, so we have that a3 is supposedly equal to, okay, so we have that 13 times 5 minus 6 times 5. That sounds like 5 times 7, which is 35. And if we look over here, okay, then it should be 2 to the power of 3 plus 3 to the power of 3. That's 8 plus 75. That's all, 27, which is also 35. So yeah, okay, everything checks out thus far. And what do we do now? Now shit gets weird. Okay, because we have recursion that's based on the two previous values, what is our induction hypothesis? Actually, that question is incorrect because we need two induction hypotheses. And what are those? They are, well, basically everything we have to do here is just decrease n plus 1 by 1, and then our other induction hypothesis would be by 2. Just to throw that out there. And yeah, maybe we need to check a4 also. Yeah, my bad. Okay, so a4 for that to work, basically. So we need two cases that are verified, so therefore we can justify our two induction hypotheses. So okay, what is a4? a4 should be 2 to the power of, okay, it should be 16 plus 81, which is 97. And it should also be 5 times 35, which is 175, minus 6 times 13. So it should be, wait, I need to write this down, 175 minus 6 times 13, that sounds like 78. And what is this thing here? Oh my god. Oh yeah, it's just 97, fuck. Of course, yeah, it's 97. And that was was supposed to be with this formula too. Okay, so this also works. So now we shall do our induction hypotheses. So we shall assume that it works for n being equal to k and k minus 1. And actually the first one I maybe should have written a bit differently, but essentially what I'm doing here is just I'm subtracting 1 from all of these indices. So our first assumption is that
ak is equal to 5a k minus 1 minus 6a k minus 2, which is also equal to 2 to the power of k plus 3 to the power of k.
And our second assumption is exactly the same thing. We just subtract 1 from k. Or sorry, when we let k be equal to k plus 1, you could say.
So ak minus 1 is equal to 5a k minus 2 minus 6a k minus 3, which is also equal to 2 to the power of k minus 1 plus 3 to the power of k minus 1.
And now I've ran out of space, so I need to erase some shit. But firstly, remember that, okay? You can do that. Good, great. Give me a second. Okay, I'm back. So, what do we want to show? We want to show that a n plus 1 is equal to 5a n minus 6a n minus 1. So you may notice that this is the exact same thing I wrote before, because then I wrote it with a starting n plus 1 instead of n. And this thing is also equal to 2 to the power of n plus 1 plus 3 to the power of n plus 1. And then, so how do we do this? I would suggest that we start with this thing here, left-hand side. We ignore this part actually. This doesn't really mean anything. So what is that? Well, since from what we had before, we knew that an, sorry, okay, I can write it again here. Okay, 5an minus 6a n minus 1. What is an? If you remember what I wrote before, you would know that an was equal to, using our induction hypothesis, our first induction hypothesis, this was equal to 2 to the power of n plus 3 to the power of n. And a minus 1 was equal to 2 to the power of n minus 1 plus 3 to the power of n minus 1. And now we just got to do some factorization. So what do we have here? Okay, well, firstly we just have, okay, we have 5 times 2 to the power of n plus 5 times 3 to the power of n. 5 is prime, so we can factorize that in a way. Then we would have minus 3 times 2 to the power of n minus 2 times 3 to the power of n, right? Because 6 is 2 times 3. And factor, we increase the exponent. And what do we have here? Okay, so we have 5 minus 3, and so that's 2, and here we have 5 minus 2, so that's 3. So we have 2 times 2 to the power of n plus 3 times 3 to the power of n, which is equal to 2 to the power of n plus 1 plus 3 to the power of n plus fucking 1, and we are done. Thank you. And of course you have to write, by the induction a axiom proof is concluded, and then you do the nice box, and then you're done. And that was everything for me. Hope you enjoyed the video. Have a good one. Bye bye.